Okay, so let's get into some examples evaluating inverse trig functions. So directions say, if possible, find the exact value. What I want to do before I start solving any of these problems is I want to construct the two reference triangles that we looked at earlier in this unit, in this chapter, the 45, 45, 90 triangle, because we're going to use these a bunch um, in this section. So 45 degrees is the same thing as pi over 4 radians. So in that triangle, the side opposite, the angles pi over 4 are going to be 1, and the hypotenuse is rad 2. And then I'm also going to draw a 30, 60, 90 right triangle, which 30 degrees is pi over 6. 60 degrees is pi over 3. The side opposite pi over 6 is 1. The side opposite pi over 3 is rad 3. And the hypotenuse is 2 for that triangle. Okay, so we're going to use those two reference triangles quite a bit. Okay, so directions say, if possible, find the exact value. For number 1, we have the inverse sine of rad 3 over 2. I apologize for my son screaming in the background. He's very hyper tonight, so but anyways, the inverse sine of rad 3 over 2. So the way I'm going to suggest you guys do these early on is going to require a little bit more work on your part, but I think it's going to help you understand things a little bit better. And as you guys practice more with this, you're not going to need to work through this intermediate step that I'm going to show you. Okay, so for number 1, we're going to set the inverse sine equal to some angle measure theta, because we know the output for any inverse trig function is going to be an angle measure of some type. So what we want to do is we want to take that equation and we want to write it as a trig equation in an equivalent manner. Okay, so if we have the inverse sine of rad 3 over 2 is equal to theta, that means that the sine of angle theta has to be equal to rad 3 over 2. Okay, so what we want to do is we want to look at our reference triangle on the right. And if we look at the 30, 60, 90 triangle, if we look at the angle measure of pi over 3, the sine of pi over 3 is rad 3 over 2. Sine is opposite over hypotenuse, which is going to be rad 3 over 2. So my reference angle there is going to be pi over 3. Okay, so when we look at the diagram that we drew up above for the inverse sine function, because the ratio is positive, that tells me that my angle measure has to lie in quadrant 1. So the angle in quadrant 1 with reference angle pi over 3 is going to be pi over 3. So theta here has to be equal to pi over 3. So that means that the inverse sine of rad 3 over 2 has to be equal to pi over 3. All right, so that right there is how we evaluate inverse trig functions. Let's do the same thing for number 2. So for number 2, we have the inverse sine of negative 1/2. Again, we want to set that equal to some angle measure theta, because the output for any inverse trig function is going to be an angle measure of some sort. So what we want to do is we want to take that equation and we want to write it as an equivalent trig equation. Okay, so here the sine of angle theta has to be equal to negative 1/2. So once again, we want to determine what our reference angle is going to be here. So when we look once again at the reference triangle on the right, when we look at the angle pi over 6, sine is opposite over hypotenuse. That is going to be positive 1/2. So we know our reference angle here is pi over 6. Now, in this particular case, our ratio is negative, which means that our angle has to lie in quadrant 4. So we want to find the angle in quadrant 4 with reference angle pi over 6. But we have to be careful here because the outputs for inverse sine have to be between the angles of negative pi over 2 and pi over 2. Okay, so I can't write the angle in quadrant 4 with reference angle pi over 6. I cannot write that as 11 pi over 6. What I have to do instead is I have to write that angle as negative pi over 6. So that fits our range or our outputs for the inverse sine function. 11 pi over 6 does not lie in between negative pi over 2 and pi over 2, but negative pi over 6 does. Okay, so this here is going to be equal to negative pi over 6. And again, I apologize for my son screaming in the background. He's really excited and he has autism, and sometimes when he gets excited, he screeches and yells a lot. So my apologies if that's breaking your eardrums. Okay, so on to example 3. Let's do one with a different inverse function. This time let's do the arctangent or the inverse tangent of -1. So once again, we want to set that equal to angle theta. So the output is going to be an angle measure of some kind. So if I wrote that as an equivalent trig equation, that's going to make the tangent of angle theta equal to -1. So this one's a little bit trickier because a lot of times when our ratio is 0, 1, or -1, that's going to correspond to a quadrantal angle. And again, a quadrantal angle is an angle whose terminal side lies on an axis. So that's like 0, pi over 2, pi, 3 pi over 2, 2 pi. But in this particular case, this is going to correspond to a reference angle, because if we look at the angle pi over 4, the tangent of pi over 4 is going to be equal to 1. Again, tangent is opposite over adjacent. That's going to be equal to 1. So that tells me that the reference angle here is going to be pi over 4. So when we look at our graph of inverse tangent, the one that I asked you guys to kind of memorize, the ratio here is negative, so that tells me that my angle lies in quadrant 4. I want to find the angle in quadrant 4 with reference angle pi over 4. And just like we did with sine, that can't be 7 pi over 4 because that's not between negative pi over 2 and pi over 2. Okay, so our range, our outputs for inverse tangent have to be between negative pi over 2 and pi over 2. So the way that we're going to write the angle in quadrant 4 with reference angle pi over 4, we're going to write it instead as negative pi over 4. Okay, I want you guys to use the same process to answer questions 4 through 8. So I'm going to have you pause the video to do that. And then whenever you're done, go ahead and turn back on, and then we'll work through these to check to see how you did. Okay, so go ahead and pause the video now. Okay, so let's go ahead and take a look at problems 4 through 8. I'm going to run through these a little bit quicker, except with the cosine inverse function, because that one we haven't looked at yet, and that one's a little bit different from inverse sine and inverse tangent. Okay, so when we look at 4, the inverse sine of 2, again, we want to set that equal to some angle theta. So if we write that as an equivalent trig equation, we get the sine of theta is equal to 2. Well, when does sine equal 2? And the answer is sine never equals 2. The only way sine can be equal to 2 is if we multiplied out front of that function by some number that is 2 or larger, which would vertically stretch that graph. Because we know that the graph of sine itself, when we go back to where we started this lesson off today, sine had to be bounded in between -1 and 1. So the biggest that the graph of sine itself can be is 1. So since sine is never going to be 2, number 4 is not possible. Okay, number 5, the inverse cosine of negative rad 2 over 2. Again, we're going to set that equal to some angle measure theta. And then when I write this as an equivalent trig equation, we want to find the cosine of theta where it's equal to negative rad 2 over 2. So I'm going to zoom out a little bit so we can take a look at like where the outputs for inverse cosine lie, number one, and also the reference triangles that we drew before starting these examples. Okay, so we want to figure out what our reference angle is. So first thing I want to do is I want to figure out the cosine of what angle is rad 2 over 2. Well, rad 2 over 2 is like 1 over rad 2. And when we look at the angle pi over 4, cosine is adjacent over hypotenuse. That is going to be 1 over rad 2. So that tells me that my reference angle is pi over 4. Okay, now the fact that the ratio is negative is different for the cosine inverse function, because when ratios are positive, the output for inverse cosine, if you look at the graph up above here, right up here, if our ratio is positive, that means the angle output for cosine inverse has to be in quadrant 1. If the ratio is negative, that means that the angle output has to be an angle in quadrant 2. Okay, so the fact that this ratio is negative, it tells me that my angle lies in quadrant 2. So the angle in quadrant 2 with reference angle pi over 4 would be pi minus pi over 4, which is going to make that angle 3 pi over 4. Okay, so that's what the inverse cosine of negative rad 2 over 2 is. It's going to be 3 pi over 4. Okay, for 6, the inverse tangent of negative rad 3. Again, we're going to set that equal to some angle measure theta. So we want to find some angle theta such that the tangent of angle theta is negative rad 3. Okay, so let's figure out our reference angle. So the tangent of what angle is going to be rad 3? Well, if we look at the angle pi over 3, tangent is opposite over adjacent, so that's going to be rad 3. So that tells me that my reference angle is pi over 3. The fact that that ratio is negative tells me that the angle has to lie in quadrant 4. And the way we want to write that angle with reference angle pi over 3 in quadrant 4, that angle is going to be negative pi over 3. So that's going to be negative pi over 3. For 7, the arctangent of 0. We want to set that equal to some angle measure theta. Again, when we write that as an equivalent trig equation, we want to find the tangent of some angle theta where that's going to be equal to 0. Well, when we look at that trig equation, that can't correspond to the two reference triangles that we've drawn, okay? Because there is no angle in those two reference triangles such that the tangent of that angle is 0, which tells me that the angle has to be a quadrantal angle of some kind. Okay, so tangent we define as like the y coordinate on the unit circle divided by the x coordinate on the unit circle. Tangent is y over x or sine over cosine. So where on the unit circle between negative pi over 2 and pi over 2 is tangent going to be 0? Well, if we look at the graph of tangent has a y value of 0 when the angle measure is going to be 0. Okay, so our angle theta here has to be equal to 0. So the arctangent of 0 is going to be the angle measure of 0. Okay, last example of this type, arc cosine of negative 1. We're going to set that equal to some angle measure theta. So we want to find the cosine of some angle theta that has to be equal to negative 1. Again, just like with the previous example, there is no angle in one of those two reference triangles such that the cosine of that angle measure is going to be negative 1. So that tells me that our angle theta has to be a quadrantal angle of some kind. Okay, so if we think about our acronym for cosine, it's maximum intercept minimum, intercept maximum. Cosine has a minimum at -1. So our first entry was 0, then pi over 2. The minimum is going to be pi. So our angle theta is going to be equal to pi in this instance. Okay, so that's the output. The arc cosine of -1 is going to be equal to the angle pi. Okay, so again, if your like the ratio that you're given does not correspond to one of the reference triangles, either the 45-45-90 triangle or the 30-60-90 triangle, it's likely you're looking at a quadrantal angle. So, and again, quadrantal angles are angles whose terminal side lies on an axis. So that's the angle 0, pi over 2, pi, 3 pi over 2, or 2 pi. So you'd look there next. If it doesn't fit one of those, then it's likely not possible to find the exact value of your expression. Okay, so what we're going to take a look at next is how we evaluate the composition of a trig function and its inverse, or an inverse trig function and a trig function.